Good afternoon, students, and welcome back to our discussion. Yesterday we were discussing periodic table, and I can remember very well we reached question number 2. And in question number 2, we were discussing the chemical family names of various groups. So I just want us to pick from where we stopped, and let us move to the next question. In our next question, that is question number 3, I want us to talk about atomic radius. Atomic radius across period 3. A question can be posed or examiner can ask you, explain the trend in atomic radius across period 3. Explain the trend in atomic radius across period 3. That's a very common question that you never miss in periodic table. And I realize that most students normally score this question wrong because they don't understand some concepts which are required by examiner here. So if such a question is asked, it can be a 2 marks question. It's very easy. What examiner requires from me is very simple. So when an examiner asks you to explain the trend across period 3, the periodic table, what you need to know as a student is that in period 3, we have the first element as sodium. Sodium is 2:8:1. The second element there is magnesium with 2:8:2. The next element there is aluminium with 2:8:3. The next element there is silicon with 2:8:4. So if you check the trend, if you check in that period 3, you realize that there is increase in number of protons in the outermost energy level of these elements. And when the number of proton increases, these normally increase the nuclear charge or the effective nuclear charge. And once the effective nuclear charge is increased, what happens? The outermost protons, the outermost energy level is pulled closer to the center, decreasing the atomic radius. So if somebody asks you to explain the trend in atomic radius across period 3, the answer is the atomic radius decreases across the period. Why? This because across the period there is increase in number of protons. There is increased number of protons which increases the effective nuclear charge, hence leading to a decrease in atomic radius. As simple as that, then you secure your 2 marks or 3 marks in an exam. Apart from looking at the trend across period 3, the next question that an examiner can ask you is explain the trend in reactivity in group 1. Explain the trend in reactivity in group 1. You know that in group 1 we have the first element there is we'll talk about hydrogen, that is 1. Then we talk about lithium, that is 2:1. We talk about sodium, 2:8:1. Then we talk about potassium, 2:8:1. But when we talk about reactivity, we exclude hydrogen here. So we are going to base our argument categorically on the 3 elements, that is sodium, that is lithium, sodium, and potassium. So how does the reactivity, what's the trend in reactivity in group 1? So if somebody say that, what do you need to know? What is the answer for such kind of question? So the reactivity increases down the group 1. Reactivity increases down group 1. Why down group 1? This because as you move from lithium to sodium to potassium, there is increase in number of energy levels. This increase in number of energy level increases atomic radius of this element. So atomic radius increases from lithium to sodium to potassium. Once the atomic radius is increasing down the group, this one decreases the effective nuclear charge. This one decreases the effective nuclear attraction. And once this one is decreased, what happens? The outermost electron is loosely attracted, hence it is very easy to lose it. That's why potassium loses 1 electron easily compared to sodium. Why? Because potassium has got more energy levels, which increase atomic radius, decreasing the nuclear charge. Hence, losing one electron is very simple. So reactivity of group 1 increases down the group. As simple as that. Another question that can be asked, that can appear in exam, an examiner can ask you, explain the trend in reactivity down group 7. Explain the trend in reactivity down group 7. Group 7, these are noble gases. I mean, these are halogens. Group 7 are halogens. And the first member of halogen there, we have fluorine with 2:7. The next one is chlorine with 2:8:7. So as you move from fluorine to chlorine to iodine to bromine down the group, realize that there is that increase in number of energy levels. And as the number of energy levels is increasing down the group, what happens? The atomic radius increases. But these are nonmetals. The nonmetals normally react by gaining. So because chlorine will have bigger atomic radius than fluorine, it will be very difficult for chlorine to gain one electron. Why? Due to the distance. Due to the atomic size. I mean, due to the distance, that's atomic radius, that normally requires a lot of energy. So it is very difficult for chlorine to gain one electron compared to fluorine. So the reactivity of group 7 elements decreases down the group. The reactivity of group 7 elements decreases down the group. Why? Due to increase in number of energy levels, which increases atomic radius, hence decreasing the nuclear charge. So gaining electron down the group will be very difficult. That's why fluorine is more reactive than chlorine. Why? Because fluorine normally gains one electron very fast because of the small atomic radius. Simple as that. Then we'll be done with such kind of a question. The next thing that you need to know here, somebody can ask you to compare the melting point and boiling point of elements. For example, an examiner can ask you, compare the melting point and boiling point of magnesium and sodium. Compare the melting point and boiling point of magnesium and sodium. When it comes to melting point of these two, these are two metals. Sodium is a metal, magnesium is a metal. When you are comparing the melting point of these two elements, you will consider the number of electrons in the outermost energy level. For instance, sodium is having electron arrangement of 2:8:1. Then magnesium is having electron arrangement of 2:8:2. So it means that magnesium has got more number of electrons in the outermost energy level compared to sodium. So what happens? Because magnesium has got high number of electrons in the outermost energy level compared to sodium, these two electrons normally increases what is called the metallic strength. So the metallic bonding in magnesium is much higher than the metallic bonding in sodium. Why? Because the more the number of electrons in the outermost energy level of a metal, the stronger the metallic bond in that metal. So if somebody asks you to compare the melting point and the boiling point of sodium and magnesium, what will you say? Magnesium metal has a higher melting point and boiling point than sodium. That is one mark. Comparing. Then you explain. The reason is magnesium has got more number of electrons in the outermost energy level, which normally increases the strength of the metallic bond in magnesium compared to sodium. As simple as that. Then there you are. You'll have your 2 marks or your 3 marks in an examination. Another question that you need to know about this periodic table, which is normally commonly tested, is the bonding. I mean, if two elements react, somebody can ask you, state the type of bond and structure which you will come up with when magnesium reacts with chlorine. So magnesium is a metal, chlorine is a non-metal. So magnesium reacts with chlorine to form a compound called magnesium chloride. Magnesium chloride is a compound formed between a magnesium and a chlorine. So because magnesium is a metal and chlorine is a non-metal, so this compound would be called ionic compound. So the kind of bond in magnesium chloride is ionic bond, and the structure is giant ionic structure.